It has a snake-like body and suction-cup mouth stacked with rows of sharp teeth. Inside,
there's a file-like tongue in the middle that flicks out and drills through the scales and skin of the fish, and then it feeds on the fish's blood and body fluids.
the sea lamprey is like something out of a horror film, feasting on the fish of the Great Lakes. The fish is native to the Atlantic Ocean. They spawn in freshwater rivers and streams, but they eventually found their way into the Great Lakes, first documented in Lake Ontario in 1835. By 1938, they were established in all 5 Great Lakes, destroying native fish populations. The use of lampricide, along with other control measures, had reduced population by nearly 95%. But
the lampreys are slimy, resilient beasts that will take advantage of relaxation and control and balloon out of control again, given the chance. Lake Erie and Lake Michigan, we saw a doubling in the lamprey numbers, and we saw significant jumps in Lakes Huron and Ontario, and we saw a large jump in Lake Superior.
And it could have devastating ecological and economical impacts on the Great Lakes.
They're just able to kill 40 pounds, I think, of fish in their 12 to 18-month feeding period. The fish in the Great Lakes are often unable to survive the sea lamprey attacks.
Gaydon says while this spike is concerning, work is underway through a binational sea lamprey control program to manage populations.
This is an amoeba. This is a unicellular organism with the ability to alter shape. Science being science doesn't leave it at that though. It has analyzed different kinds of amoeba and declared several types. One of them is called Naegleria fowleri. It's a famous one. This is called brain-eating amoeba, and it's just as deadly as it sounds. Recently, the amoeba claimed its latest victim, a man in the US state of Georgia. The amoeba destroyed his brain tissue and he died from it, much like the 2-year-old boy from Nevada who died from the infection earlier this month. How does this amoeba spread its disease? It infects the body and causes damage to the brain, hence the name. It lives in soil and freshwater lakes, rivers, ponds, and hot springs, basically warm environments. It's not found in saltwater like in oceans or properly treated swimming pools. It enters the body while someone is in the freshwater. The water enters the body through the nose. So does the amoeba, and then it travels to the brain. What do the symptoms look like? They usually come on strong, and they progress rapidly, within 5 days of contracting the disease. They include headache, fever, nausea, and vomiting. Later, the situation worsens and symptoms increase. They progress to stiff neck, confusion, seizures, hallucinations, and coma. And all of this usually leads to death. The infection kills about 97% of the people it infects. It's often a losing battle. There is no consensus on effective treatment against it. Brain-eating amoeba may be fatal and hard to detect. According to the WHO, anywhere between 1 to 2,000 cases have occurred globally. They are mainly seen in Australia, Europe, and the US. In the past 5 years, the US has seen 3 cases each year, and cases have been on the rise worldwide. Now, while this amoeba is a cold-blooded murderer, it likes warmth. Because of climate change, our world is heating up, so more places are warmly welcoming this amoeba. For instance, most infections in the US happened during the summer, and they happened in the south. But in the past few years, they have been moving upwards. Infections are cropping up farther north during bouts of extreme heat. Only last year, this amoeba was identified in South Korea for the first time. In India, the first case was detected in 2016 in the state of Kerala. Following this, there have been a few cases in the country, mainly in the southern states. So, more countries are seeing cases of this infection. Since 1962, only 4 people have survived it. So, how can you avoid it? Experts say assume it's present in every freshwater body. So avoid jumping in. But if you can't, try keeping your head above the water, because it could save you, both literally and metaphorically.
Leprosy cases are surging in Central Florida. The CDC is warning the disease is becoming endemic in the southeastern United States. A recently published research letter from the Centers for Disease Control and Prevention says Central Florida accounted for 81% of cases reported in the state. That's almost 1/5 of cases reported across the U.S. Leprosy, also known as Hansen's disease, is a chronic infectious disease primarily affecting patients' skin and nerves. It's spread easily through extended close contact. If the disease is not treated, it can cause serious symptoms like blindness, ulcers, paralysis, and the crippling of hands and feet. The age-old bacterial disease has long been feared as a highly contagious, devastating condition, but knowledge around it has grown. There is a treatment that usually lasts between 1 to 2 years and involves a combination of 2 to 3 antibiotics. But the CDC says stigma around the disease remains, and that those suffering are often isolated and discriminated against. According to the World Health Organization, medical officials reported more than 200,000 cases of leprosy every year in more than 120 countries. The CDC states that about 150 people get infected with the disease in the U.S. every year. In the letter from the CDC, officials say the report demonstrates a gradual increase in the incidence of leprosy in the U.S. and that the number of reported cases has more than doubled in the southeastern states over the last decade.
An electrogenetic interface. That's what scientists at the ETH Zurich University are calling their new discovery. They have found a way to talk to human DNA, to give human genes commands using electricity. Thus the name electrogenetic. The scientists from Switzerland just published a paper detailing their findings. They are quite excited about the potential their research has in the field of wearable electronic devices. Let's first talk about what they did, how the scientists proved their concept. They took a mouse with type 1 diabetes and attached some human cells to it. The human cells were capable of producing insulin. That's the essential hormone that controls your blood sugar levels. People develop diabetes when their bodies are unable to regulate their blood sugar levels on their own. Coming back to the experiment with the mouse, the scientists had put acupuncture needles into the test subject, right where the human genes had been attached. This allowed the scientists to transmit commands to the human DNA via electricity, almost like a small electric shock to tell the human genes to start making insulin, and it apparently worked. The scientists say their electrogenetic interface allowed them to supply insulin to the mouse in a timely manner, that too by using a standard set of AA batteries. Now imagine what this could do for diabetic humans. We could wear a watch-like device that could trigger regular insulin production. A machine could take over for our failing DNA and keep our blood sugar levels in check. That too on a timer. No more alarms to remind you of your insulin dose. And that's just the beginning. The technology doesn't need to just focus on diabetic patients. It has the potential to alter medicine as we know it. Imagine telling the genes that are causing cancer to just stop. Imagine pressing a button and suppressing a rare genetic condition. May sound like science fiction now, but this research could pave the way towards that future.